All right, so generally what I've been doing is I've been just going through the section since normally you don't have the book open, and I just kind of go over the important topics in each section. All right, and of course we already know this, but the triangle sum theorem just says what? Yeah. The angles of a triangle add up to 180 degrees. All right. Everybody okay with that? All right. Now what we're going to do is we're going to prove that. All right. Now the one thing with this proof is they actually talk about an auxiliary line, all right, in this proof. And basically just an auxiliary line is just an extra line segment drawn in the figure to help analyze, all right. But I say it a little bit differently, all right. So we'll kind of look at that. We'll kind of look at that and see. Now, again, this is the proof. All right, so let's go ahead and write that down real quick. All right. Let's start with this. Now, again, all we're doing is we're given that we have a triangle. That's it. All right. And we're going to try to draw a triangle ABC. All right, so all we have is triangle ABC is what is given. All right, now the next part, it says draw AD through a parallel to BC. All right, that would be obviously this line right here that you're drawing. All right, and they mentioned something about they call that like an auxiliary line. It's just a matter of how you see it. Through any given point, there's exactly one line parallel to another line. So I agree with that? All right, so that's kind of what I would put down. Through any given point, there is only one line parallel to BC, and that's the what? That's the auxiliary line that they're talking about. All right. So their answer here for number 2 was an auxiliary line. I would just write down through any point there is exactly one line parallel to BC. All right, and so what did we do? We drew that line. All right, we drew the parallel line through A that's parallel to BC. All right. Everybody okay with that? All right, now let me just show you again how simple it is to prove this. All right. The first thing we want to do is we would say that angle 4, and let's just highlight it so we can see it. Angle 4, bless you, and BAD form a linear pair. All right. And that, of course, is just the linear pair postulate. Well, actually, sorry guys, it's definition of linear pair. Sorry. Bless you. Definition of linear pair. Now, angle 4 and angle BAD are supplementary. That's the linear pair postulate, okay? Which to me seemed a little redundant, okay? But now why does angle 4 plus the measure of BAD equal 180 degrees? Yes, definition of supplementary. All right, if they're a linear pair postulate, this is how I think it could be condensed, but this is just their proof. Definition of supplementary. If something forms a linear pair, then it's automatically supplementary. All right. Now, somebody tell me why the measure of angle BAD is equal to the measure of angle 2 plus the measure of angle 5. Come on, we can do this. So this angle right here, there you go. Thank you very much. Angle addition postulate. All right. Angle 2 plus angle 5 equals BAD. Angle addition postulate. Angle addition postulate. Now how did I get to the next step, somebody? Why is angle 4 plus angle 2 plus 5 equal to 180? Good, tell me.
Substitution.
Yeah, substitution. What did we substitute? So we looked up here at BAD, correct? And BAD here. And BAD is equal to what? 2 plus 5, so I just replaced it. Does everybody see that? So that's a substitution. Now somebody tell me why angle 4 is congruent to angle 1 and 5 is congruent to angle 3. Come on, somebody be brave. Why is 4 congruent to 1 and 5 congruent to 3? Wow, tell us again.
Alternate interior.
Very good, man. Alternate interior angles, right? Alternate interior angles are congruent. Very good. Now went from congruent to equal, so those are just what? Right, definition of congruent. And then what? Yeah, does everybody agree? Does everybody see that? You're just replacing 4 with 1 and 5 with 3. Substitution. So we've just proven the interior angle theorem. All right. Some of the interior angles of a triangle always add up to 180. Everybody good with that? All right. Very good. Very, very good. All right. That's kind of important. All right, I see somebody's still writing, so I'll give you another second. Thanks for writing that down. That's kind of important. Plus, it's just a good review. All right, good review. All right, let's look at the next thing now. All right, so now we have triangles, right? We have what's referred to as interior angles, and we have what? Exterior angles. I'm pretty sure you can tell me what an interior angle is, and I'm pretty sure you can tell me what an exterior angle is. Right? Now, there's one last thing that's kind of important. All right, so look right here, guys. This is an exterior. These two over here are your remote interiors, because that's in relationship to the what? To the exterior angle. Because now we're going to prove something that's kind of cool, actually, that will help you on some standardized tests, if you remember this, that the exterior angle is always equal to the sum of the remote interior angles. All right? And that's the next proof I think we're going to do. It's very easy. So what we're trying to do right here is we're going to demonstrate why angle 1 is always equal to A plus B. All right, should be pretty easy. Now, let's just do something so you can see it. All right, I'm going to give you an example over here, and then you can see how obvious it is. All right, so somebody tell me what they think this angle measure is about. Somebody give it a shot. I don't care what. 45. All right, if that's 45 degrees, what's this angle right there? About. What do you think?
Like
110-ish. All right, we'll go with 110. All right, I'm pretty happy with that. So let's put 110 degrees here. So then the third angle would have to be what then?
120.
Would it be 25? Everybody happy with that? Does everybody see that? It doesn't have to be. It's just, we just know that's possible because they add up to what?
180.
They add up to 180. All right. So now what would the exterior angle be, guys? 135, right? So is what they're saying true? Yeah. All right. Now the question is, how do we prove that's always true? Because we just proved that it's true in this case. All right. Does everybody agree? How do we figure out that that was 135 degrees?
Because the two.
No. Well, that's true, but there's another way.
Supplementary.
They're supplementary. You're right, though. You're both right. You with me? You were using the theorem we just learned. But I'm saying what I would prefer that you see is that's obviously supplementary, right? They form a linear pair. Do I agree with that? And then these angles add up to what? 180. So now, what angle do they have in common? They have the 45 in common. Does everybody see that? They have the 45 in common, right? So we can write a formula with that 45 degree angle with the triangle and 45 degrees with the linear pair. Does everybody see that? Everybody good? All right. Yes.
How do you know if an angle is remote?
Well, that's a good question. The remote just means away from, right? So these two angles are separated from this angle.
Oh,
You see what I'm saying, right? They're all three interior. One is connected, one's not connected. All right. So now what we're going to do is I'm going to jump down here and we're just going to prove it real quick. All right, we're going to prove it real quick. All right, so the first thing we're going to do is we're going to say step 1, we have triangle ABC, and that's what? Given. Come on, guys. Now we got to write it ourselves. Somebody want to help me? Step 2. I tried to give you a hint the whole way through, so you should feel good about it.
angle 2 and angle 1 or something.
Okay, let's do this. Again, I don't really like how I don't like how this does it up here. All right, does everybody see what I'm saying? Like, to say that it forms a linear pair, then to say that it's supplementary, then to say that it's 180. I'm trying to explain. I'm gonna reduce this down. Does everybody agree with that? So if we say it's a linear pair, then it's automatically what? It's automatically supplementary, and if it's supplementary, it's automatically what? 180 degrees. We all know that. All right, so I don't want to make you write it all 3 steps out. All right, so here's how I want you to do it. All right, so I like what he said. All right, so we're going to say angle 1 and 2 form a linear pair. Right? And if they form a linear pair, that's because it's definition. Everybody okay with this? Definition of linear pair. All right. And now we can say that angle 1 plus angle 2 is equal to 180 degrees. And I want you to say that's the linear pair postulate. And to be honest, if you write it in some type of way, I'm okay with that too. All right? Hopefully you understand what I'm saying. That's what I want you to write. Angle 1 plus angle 2 equals 180 degrees. All right, so if they form a linear pair, it's not necessary to say they're supplementary. All right? That's part of the linear pair postulate. And some books just differ in that minor respect. All right, so somebody else now tell me, what can we say? Think back to how I just showed you with numbers. What can we say? Come on, give it a shot.
Angles A, B, and C, like
That's exactly right. Very good. Except I can't really call it C, right? I would have to call it angle. Yes, very good. All right. Now we proved the sum of the interior angles, right? So we can say now for angle A plus angle B plus angle 2 equals 180 degrees. And they call that the triangle sum theorem. Come on, guys. I want someone else to tell me what's next. I'm not doing it. Come on, somebody speak up. Someone who just doesn't always tell me the answer. Just give it a shot. Good.
You could. Wait, never mind.
Come on, come on. Don't
Also
say never mind.
You could do angle A plus angle B plus 1 equals 180. That's substitution, but that wouldn't work because we don't.
Well, you're right. It's a substitution, but you just got to get the substitution correct.
Yeah, we don't know.
What is the substitution?
I was actually gonna say that angles A, B, and 2 congruent.
No, we don't know that. We don't know that. What? Yay! Good job. Good job, guys. So remember, you're trying to combine as you go down. Look right here. This, they're both equal to what? So everybody agree with that? So that means now what? That, she said it correctly. Angle 1 plus angle 2 is equal to angle A plus angle B plus angle 2. And that, of course, is just of what? Substitution again. Now, it's possible that they're all equal. Emily, do you understand me? But do they have to be equal?
No.
No. See what I'm saying? It's possible, but they don't have to be. And that's why I kind of did it not equal over here. All right, so you can see that. All right, so now what am I going to do, guys? Good. Drew. Angle 1 equals angle A plus angle B. Beautiful. That was the what? I mean, I can't really. You know what I mean? Your degree is just subtracting, right? You're just subtracting angle 2 out from both sides. So I would say the subtraction property of equality, but that's good. Now, come on, guys. Isn't that easy? Right, so what you're trying to do is you're just trying now not to be able to just say that's true because I say it's true. All right, everything you do in math can be proven true or not true. All right, and this is just the beginning. All right, math is, believe it or not, amazing. When I took some of my college classes in geometry, we had to prove the angles of a triangle could add up to 180. We had to prove they could equal, they could be more than 180, and we had to prove they could be less than 180. All right. So that's called non-Euclidean geometry. All right, which is absolutely incredible. Those of you guys who are interested in math, math never ends. All right, never ends. They're always discovering something. And like I said, this is just the beginning. All right. And believe it or not, lots of high school kids are coming up with their own proofs in geometry. There's a recent one that was published, I think, by a high school kid in geometry that they've been trying to prove for a long time. And I think it was some girl in high school that proved Sum Theorem. All right, and it's really interesting. They also have people are working on it. There's some foundation that is giving out like $1 million rewards if you can prove this, or $1 million reward if you can prove that. All right. So again, obviously, it's a little bit more challenging because they've been working on it for centuries. But eventually, they will figure it out. All right. So again, I don't think that's that hard. Some of you, I feel like you're getting better at it. All right, than others, especially. But again, I'm saying just review. All right, just review the notes. All right, I think that would be helpful. All right, now let's look at, obviously, the problems. All right, so now let's start with number 1. All right, I'll try to blow it up and help you with these. All right. All right, so now number 1. All right, I would like you to do it without a calculator. All right, and I'm really trying to work on some of you guys in your mental math because I want that to obviously be better. How do I know quickly that the answer is 58? How do I know it's so fast that it's 58 without much thought? What? Well, here's what I'm trying to tell you. Now, again, I'm not saying what I'm doing is correct. I'm just simply saying some of you guys, I want you to try to be better at your mental math. And the only way you can get better at mental math is by listening to what I'm saying. All right? If the angles are congruent, they all add up to what? Or they're all equal to what? I mean, each individual angle. If the angles are congruent, they equal 60. Please listen to what I'm saying because it'll help you solve a lot of problems. So to me, they're all 60. You see what I'm saying? So this is what? 3 degrees over. And this is what? 1 degree under. So that means 2 over. So this has to be what? 2 under. All right, so that's automatically 58 to me. Does everybody see that? All right, I'm not saying you can't just, some of you are fast enough to do 63 plus 59 subtracted from 180. That's fine. All right, I just think it's easier to visualize the numbers and understand if they're close to 60, the answer is really easy to find. All right, any questions with that? All right. All right, so let's look over here at question number 2. I'm supposed to find, obviously, I get really frustrated at kids who do the math on finding angle 1. What is the obvious answer to angle 1? Say it, Reed.
That would be...
No, don't. Listen, there's really not much calculation is what I'm trying to tell you. All right, it is 42. But let's look at it. If this angle is 90, these two angles have to add up to what?
45.
90. You're right. They're close. You're right. But to me, let's start out with this. If that's 90, the two acute angles have to be what? 90. Everybody see that? So if that's 48, the other one have to be 42. Right? Those are little types of things. You don't need a calculator for this. I especially don't want you going 90 plus 48 subtracted from 108. All right? Now, if this is 90, that makes this whole angle down here 90, which makes angle 3 what?
45.
39.
51.
What is it?
51.
51. And I don't care if you make a mistake. All right? But I also get frustrated because I can't come around and see if you're participating or if you're just putting 51 down because I just told you it's 51. Right? That's what I'm talking about, getting smarter. All right? You're supposed to, when I ask you what you think that angle is, Say whatever you think it is. 39 is fine. Who cares? 39. I thought it was 39. All right, 45. I thought it was 45. Now I just told you it's what? 51. How do we know it's 51? Because that's a 90-degree angle. How did I know that's a 90-degree angle? Because these are parallel. If these are parallel, the consecutive interior angles are supplementary. So if that's 90, that's 90. Everybody's with me, right? That's 51.
So 39, whatever. Oh, I get it. Because the theory of alternate interior angles, that has to be.
Well, now we can just quickly tell me what 2 is.
39.
2 is 39 because they are alternate interior angles. Right? I'm telling you, though, that angle C and this angle D are congruent. Because if that's 90, that has to be 90. Because they're consecutive interior, not consecutive interiors are supplementary.
Oh, that makes more sense.
Right? So now that's 90 and that's 90. Perfect, guys. That's exactly what I want. All right? Speak up if you don't know what I'm saying, though, too. All right? All right, I thought that was kind of easy, so let's try number 3. All right, so now obviously we're using the exterior angle theorem. So angle 2 would have to be what?
80.
80. You're right, 80. Right? Now, do you have to remember the exterior angle theorem? No, because what's happened is you would figure out what that angle is, right? And then you would subtract those 2 angles from 180. And then you would realize what the answer is. All right? Or we could just say the exterior angle minus 32, which is 80 degrees. All right? And these are the SAT type questions. That's why I like to spend a little extra time on this. A lot of SAT and ACT questions are dealing with interior angles. Okay, so MPQ now is pretty obvious, right? Now listen, you shouldn't be doing 6 plus 5 and carry the 1 anymore. If you're doing that, slap yourself in the face and say stop, right? You're adding by going what? 50 plus 40, which is what? Plus 5 plus 6, which is? There you go. That's what you're doing. All right? We're not adding 56 plus 45 and carrying the 1. Does everybody agree with that? All right? Your mental math has to be sharp. 56 and 45. You should look at that as 50 plus 40 plus 11. 101 degrees. Any issues with that now? All right, remember what I said. You're practicing your mental math right now. All right. So, obviously, something happened when this was copied. So, I don't really care about the picture. So, get rid of that. This one down here, though, is kind of important, so I'm going to finish drawing it out. Here and here. All right, so we need help with this. All right, so your job right now is to try to figure out what angle 1, angle 2, and angle 3 are. All right, I don't care what order it is. All right, so somebody tell me how they figured out 1 quickly. Tell me, Charlotte.
I just did 90 plus 30, and
Okay, what if we could do it even much quicker than that? Tell us, Dalton. Yeah, okay, so I understand what you're say it again.
90 minus 29.
Yeah, 90 minus 29. Charlotte, I'm not sure if that's what you said now that I think about it. Is that what you said? No, because you were adding, I think this is what I'm trying to explain to you guys. And this is frustrating to me because I want you to know anytime you see a right angle, the 2 acute angles must add up to what? They must add up to 90. Right? Does everybody understand what I'm saying now, right? So we can just mental math 90 minus 29, right?
61.
Yes, and we have 61. Thank you. Right? Is everybody good with that? So that's 61. All right, now obviously angle 2. What do you think, Ava? I want you to tell me how I would find angle 2. Put your hand down. She's brilliant. Now, what you're thinking about is the exterior angle theorem, right? I want you to look at lines. That's what I want you to look at. So here we go. I'll draw it for you so you can see what I'm talking about, just to make sure. Oh, that's too big, but that's that line. So I want you to think of, and again, I do understand some problems because there's lines everywhere, so it's kind of confusing. So if you don't mind, I'm just going to cross this out. Yeah, you know, that's the most important thing that helped me out when I was first trying to figure all this out, was if there's a bunch of lines, I used to just cross them out or erase them or do something. Draw them separately. It's much easier when you do that. It's very hard to visualize, all right, sometimes, especially when there's so many things in the way. All right, so now you're going to do 180 minus 29. Okay, be careful. 51 is correct, but think about it now. So again, here's how I want you to think about it, right? Even though you're right, 180 minus 29, right? I tell kids you should do 180 minus 20. See what you forgot? You forgot the 100. Well, what's 180 minus 20? How much? 180 minus 20. Now you're with me. You see what I'm saying, right? All right. So this is the mental math here. That's why I say 160. And then 160 minus 9 was your what? I'm listening. Was your what? You had it right. You said 51. Instead of 51, it was what? Don't help her. Yes. And then we're subtracting 9 from that. There you go, girl. 151. That's 151 degrees. All right. And again, this is what I think we have to be better on as far as the mental math, right? You see what I'm saying? It just bothers me when kids are going 7 and 10. That's annoying to me. You shouldn't be doing that. All right. Subtract out 180 minus 20 and then minus 9. It's much easier that way. What?
It's a lot easier if you round to the near, it's like the 10th place. So
yep.
You do 180 minus 30 and then you add 1.
That's 100% correct. And that was the next thing we were going to talk about, honestly. Very good. All right. Whenever you're subtracting 9, it's better to subtract 10 and add 1. All right. That should be something pretty fundamental. All right. So now, how do I know quickly what angle 3 is? Tell me, Kian.
Well, you do the under 51 plus 17.
Nope. Quicker. Even quicker. Someone else. I can look at that and say it's 12 degrees without doing any work. Just 12. Why is it 12, Drew? 29 minus 17 is 12. Right? This angle plus this angle equals that angle. You agree with me? And again, are you going to get the right answer doing it however everybody else said? Yes, you can add that up and you're going to get the same answer, right? No problems. I'm just saying, you know your relationships. The time that it takes you to do each problem is simple. The time it takes to do each problem is simple. Everybody agreeing with me on that? All right. All right, let's try something else. And again, 13 is obviously out of here because I don't know what happened on that. All right, I hate these dumb pictures. All right. So here we go. Let's look at 14. I don't know why they just don't draw the picture like, yeah, I'm looking at a folding or tent. Yeah. All right, everybody goes out and measures the angles of your tent, right? So dumb. All right. So here we go. Now, I want everybody to take a look at 14. Everybody take a look at 14. Now, something that's kind of hard to see is this right here because of the way I take this picture. That angle is what?
Congruent to that.
Yeah, I think what they're trying to tell you is those two angles are congruent. All right, those two angles are congruent. All right, so, what are those two angles?
75 degrees.
Tell us. Come on, tell me what you're doing in your head. It's okay. Because most of the time, I prefer the fraction as opposed to the decimal.
Oh, okay.
So what were you doing in your head?
I was doing, it would be 37.5.
Yeah, you're so stubborn. 70, you were doing in your head 75 divided by 2. That's what I wanted the answer to be. 75 divided by 2. So everybody agree with that?
I did 1 equals 40 and 2 equals 35 because I just did 75 times 2 things that add up to 75.
But they have to be what?
Oh,
Like
and then
speaking
one
room.
They have to be congruent.
I didn't divide by 2.
That's exactly right. I knew exactly what you meant. All right, it's no big deal. It's 75 divided by 2. And I appreciate the fact that everybody in here should know that's 37.5. 37.5. You should just know that. All right? Everybody good on that? All right. So now, how do I figure out what angle 3 is? I don't want the answer. I want you to tell me how to get the answer. All right, Virginia, thank you for volunteering. What did you do? Which is what? Come on, no. Visualize. Remember what I told you. Here's what I'm trying to show you. Come on, we can do this. 180 minus 47. So we're going to do 180 minus 40. What's 180 minus 40? Minus 7. Thank you. That's it, girl. Good job.
Thank you, Mr. Stroh.
All right, guys, this was a nice day, man. Good job. Good job. All right. Finish it up. Yes, I appreciate you guys very much. Today was outstanding. Great job. Great job. Yeah, those numbers up there. It's pretty easy. It's mostly math, just figuring out angles.
I like those. I like those all.